Good afternoon, everybody. I trust you're all well, safely sitting in a nice home office or home environment, and looking forward to this, the second session today. For those of you who attended this morning's session, thanks for coming back. You must be suckers for punishment. This afternoon's session, we're talking about certifying premises fiber using an optical loss test set. Essentially, apart from a few slides, I plan to spend most of the time actually stepping through the setup on our CertiFiber Pro. I don't know whether it'll be practical for anybody else to follow along. If you'd like to, you can have a go. But obviously, I can't see what you're doing, and you can't necessarily see which buttons I'm pushing. So we'll get started now. Enjoy. Right. Certifying premises fiber performance with an optical loss test set. This is something that an awful lot of our installer customers do regularly. It's something which our end customers expect to see the results from on a regular basis as well. So this is not neither rocket science nor is it unfamiliar to a lot of people. If we start from a similar position that we started from yesterday, we are having or we're experiencing increasingly tight power loss budgets. That is because end users are pushing all the time for better performance, and the manufacturers of electronic hardware likewise are finding ways to use more and more of the bandwidth. So we are looking for less and less loss in our installed links, but equally it's important to be able to repeat a test twice, sometimes only a day apart, sometimes months apart, and to get repeatable test results out of the test equipment. Whether it's the same test equipment or different test equipment, we should still be able these days to achieve the same test results. And some of those are down to a number of changes which we've undergone, or we're undergoing, perhaps more accurately. First, I wanted to just cover off the issue of, should I be certifying with an optical loss test set or with an OTDR? And this is what the standards organizations have to say about it. Both the TIA, our American brothers, and the ISO, the International Standards Organization, and the IEC, all offer essentially two levels of test, either tier 1 or the basic, or tier 2 and extended. But in both cases, they are both entirely convinced that basic test regime requires light source and power meter testing. The extended test regime enables you to add the OTDR trace to the light source and power meter reading. It's not a matter of one or the other. If you're going extended test regime, it's a matter of one and the other. So you're required to do both. And that's what's highlighted in the sexy purple box. So the extended supplements the basic test regime. It does not replace it. So that was a short thing to cover off that. We need to know every time we're preparing to test with a light source and power meter or an optical loss test set, why are we testing? What are we trying to prove? Is this a question of performance confirmation? That's what I broadly term when we're testing for the client, basically to support our invoice and make sure that he knows that he's paying for the job that we've done. A different question is, are we testing for warranty provision? Because warranty providers are pushing for better and better performance out of their connectors and their fiber. Their installations are offering or promising lower and lower end-to-end losses. And If we're testing for warranty, then it's quite possible that our warranty provider may require us to use a custom test setup. Different losses per connector, different losses per splice than that which is offered by the ISO and TIA standards. Last, if we're fault finding, how are we going to go about it? And from that point of view, important stuff is, what are we testing? So what type of fiber is it that we're testing? What core size? What connector type? And do we have the correct test cords, adapters, connectors to fit to our test equipment to enable us to make these connections directly? Bearing in mind, we are not into all sorts of hybrid complex patch cords, hybrid connectors and things like that. They are not what is recommended or required by the TIA and ISO standards. It's useful to know what configuration we're talking about, what the approximate length of the installation is, and do we know what cable IDs are involved. The question, when are we testing, is relevant, particularly if we're testing an unfamiliar set of connectors or a different core size to usual, because then we need to order up the appropriate test cords, the appropriate adapters, and the appropriate connectors for the top of the tester to make sure that we are able to connect to the link under test in a standards compliant way. This is not Fluke Networks being picky. This is the standards having written into their specification that the requirement is that the connectors should match appropriately. So one of the things that we always cover is cleaning and inspection. This is end-face cleaning. Those of you who were on the webinar 2 minutes early will have seen that I was diligently cleaning all the cords that I'm going to use in my demonstration. And this is what a clean connector should look like through the camera-driven fiber inspector. Hopefully, most everybody has seen that a clean connector. One of my early fiber instructors said, your connector should look like a wheel on the sand, but there should be no seaweed, rocks, or anything else in view. It should just be the wheel and the sand. Obviously, if we have a contaminated end face, such as this one in image B, this is off the back of my hand and a shirt, which is why it's all smeared. We have a condition where, because all of our connectors these days are PC, they are all physical contact connectors, if we plug connector A into connector B and then review the condition of connector A, we get this. And this is a classic contamination ring as a result of one clean connector being in contact with one dirty connector. The slightly domed shape of the end face across the ferrule means that the contamination is forced into this circular configuration. One thing to bear in mind is that if your contamination ring is as offset as that appears to be, there is a reasonable chance that one or other of the end faces is not perfectly centered, because perfectly centered should give you a perfectly central contamination ring. Anyway, I've cleaned all my fibers and I am confident that I can get a decent result out of them, said he bravely. Really important thing at the bottom of that slide, clean your measurement cords after every test. That's the only way to maintain consistency of test result. It's the only way to achieve repeatability out of your tester for subsequent tests. So keep the cords clean at the interface with the installation. So here we come on to basic tests, are my favorite bit. and this is where we're going to look at 4 essential components of getting consistent test results, which is what we're driving towards with this repeatability issue. First and foremost, something that you rely on Fluke Networks for is power meter performance. You expect us to produce an accurate, repeatable, reliable power meter. That's what we build into the Certifiber Pro. We build 1 into each end, so you get 2 of them. Likewise, the light source performance is crucial. It needs to be consistent, and it is, provided we remember one important aspect, and that is you must stabilize the sources in both the main and the remote unit before you start to test. That basically means you switch them on and leave them alone for about 10 minutes to stabilize their output. We prefer the 1 jumper reference. Why? Well, fundamentally because the 1 jumper reference is the simplest reference method available. It involves 1 cord from the output of the tester to the input of the remote, and 1 cord from the output of the remote to the input of the main unit. And it's called the 1 jumper reference. There are no joins, there are no additional bits and pieces, there are no connections in between the source and the meter. And then last but not least, certainly for multimode, encircled flux compliance is a standard requirement. It's a standard requirement in TIA, it's a standard requirement in ISO. When EN catches up, it will be a standard requirement in the European norm as well. The important thing here is that encircled flux is designed to ensure that different pieces of test equipment on different days of the week at different times should produce the same quantity and quality of light, plus or minus a small amount. So encircled flux is absolutely key. It's repeated on the next slide, so I'm not going to go on too much. But the use of test reference cords is crucial. Only test reference cords will provide, in our case, encircled flux compliance right to the end of the cord, but equally they are the only cords that will provide consistency over time. Not that you have to use the same cords, but you have to use test reference quality cords every time you test if you want to get anything like the same kind of performance out of the installation. So encircled flux, there we go. We've had various iterations of control for light sources. CPR, the coupled power ratio, was in effect from about 1997 onwards until 2006 when modal power distribution took off. But unfortunately, both of them allowed too big a window for the test equipment manufacturers to provide light power through. And the net result was that we had up to 30 or 40% difference in test results, which is obviously unacceptable. So encircled flux compliance produces a much tighter window with a variance probably in the high single-digit percentages between the best source and the worst source available that is encircled flux compliant. So, moving onwards, we're going to look at all of these parameters, or rather all of these segments of the setup of a test as we run through this. I've left myself 17 minutes to do it in, so hopefully I'll get this done. What I'm going to do now is I'm going to bring my Certifiber Pro display to the fore. There it is. It is connected and it is currently set up in the fiber inspector mode. So I'm going to press home and take me to where I normally work. Just one moment, if you please. There we go. So this is Certifiber Pro front screen. The project that I have adopted for today is called the Zoom webinar for today, which is very exciting. And I am now going to set up, or I'm going to go and inspect the different types of tests that I can choose. So here on the screen, you can see this is a Certifiber Pro quad unit, that's multi-mode and single mode. And the test types that are available to us are the smart remote, which is the one that typically we use. That's where we use the main unit and the remote, and the two of them talk to one another, and we test pairs of fibers at the same time. However, there are other options hidden behind there, one of which is called loopback. And that is a convenient option if you are forced to test by yourself. What it enables you to do is to use only the main unit as both source and meter, and to install test cords or patch cords, if you have enough headroom, at the far end between transmit-receive pairs, and test each pair as a single fiber. It's not recommended in general use, but if you have no other option, then it can work. Far end source is for testing single fibers. That's where you set the remote unit up as a permanently emitting source, and you can then make measurements over distance on single fibers where you don't have the luxury of a pair to play with. So into that. So that is what far end source would look like. The rest of the test setup we'll get to in a minute, but we're actually going to use smart remote. So the first question that we have to answer is, if we're testing smart remote, do we need or do we want to test bidirectionally? That means, do we want to test each fiber both upstream and downstream? And good practice says, why not? So we'll turn it on. And there it is. And then we have, of course, we have borne in mind the question of stabilization of our sources. So obviously the main unit is switched on because you can see it, so it's stabilizing its source, but my remote unit is also switched on and is also stabilizing before we go any further. So we now need to think a little bit about the fiber type, because there are multiple options here, and let me direct you to this. So if I touch the fiber type, we obviously get a list of fibers which exist in the tester. And as you can see, not only are there generic OM3 and OM4s, but there are also manufacturer specific ones. Now, if we touch the more down in the right-hand bottom corner, we get last used, custom fibers, generic, and manufacturers. If I touch generic, that will show us all of these which we are used to. If I touch manufacturers, then I will have a list of the available manufacturers. These are the manufacturers who have provided Fluke networks with a list of fiber names, types, and performances, which we can load into the tester. So picking at random here, I'll pick Corning because they have a nice selection. And as you can see, there are Clear Curve OM4, OM3, OM2, Infinicor's Clear Curve single mode. One thing you may notice is there's no OM5 there. That may be because Corning have not yet provided us with detail on that. Typically, we update the library. We try to update the library twice a year. So sometimes there is a bit of a lag. Equally, the manufacturers do not necessarily remember to tell us exactly when they launch a new fiber. So we're going back because we're going to go generic on our setting, and we're going to choose OM4 multimode 50 because I like that one. We do not need to touch the fiber type settings because those are defaulted. However, when it comes to the test limit, we have huge numbers of choices. And let's just think a little bit about this. So the international toughest standard currently available in the world is this one, the ISO IEC 14763-3 of 2014. That is the installation test standard with the tightest internationally recognized loss parameters of any fiber standard worldwide. It's marginally tighter than the TIA 568. It does require some things. Let's have a quick look in amongst the other test limits, because obviously there are test limits like the TIA and the ISO, which are what I would consider installation limits, but there are also application limits. So for instance, down here, second from the bottom, we see 10 Gbase SR. That is an application limit. It essentially provides for a fixed length and a worst case maximum loss. It is not concerned with how many connectors, how many splices, any of that stuff. It's just concerned with end-to-end performance loss and maximum length. Those are the only considerations for the application standards. But if I go more, as you can see, I've got last used, custom limits that we'll come to in a second. We've got the TIA, we've got the ISO, we have the application standards, and if I select that for a moment, here are all the different speeds, all the different transmission configuration types, all built into the test limit selection options. I'm not going to choose one of those. I'm going to go back, and just for the fun of it, we're going to set up a custom limit. I'm going to imagine here that I'm creating a new custom limit, and we're going to call it Zoom 50. There we go. And the maximum length that we're going to allow is going to be 500 meters, because that's reasonable. And this is a length-based limit, not a fixed limit. A fixed limit would be you are allowed 3 dBs end-to-end on 500 meters. Now, this is a length-based limit using connectors, not MPOs. And we go. So here is what we're working on. Our connection loss is going to be 0.3 of a dB. Our splice loss is going to be 0.25 of a dB. Our loss per kilometer we'll leave at 3 dBs, and we'll say that's done. So here we have connection loss of 0.3 of a dB, a splice loss of 0.25 of a dB. Here are our length losses, and this one we need to change to NA because it's not applicable. This one we'll change to NA as well because it's not applicable, and we hit save. And then we can choose Zoom 50 as our test limit for the purposes of this demonstration. And our reference method is one jumper. And you'll see what that means in just a moment. The connector type in this case is actually Sierra Charlie. And the number of connections and splices is 2 and 2. Now, I'm going to just hover on this just for a second, because up until about 3 or 4 years ago, about a third of the fiber installation industry would have looked at that and said, well, that's 4 connections. Gentlemen, we all know now that you only count in the worst leg of your installation. So if you have an installation which is 3 connectors and 6 splices, and that's what you declare. But in this case, you only look at one leg of the installation. So we've got 2 connections and 2 splices. And we hit done. And here is our fiber test setup. Now, okay. Now, so at this point, we're ready to hit save. So I'll do that. I'll hit save. And our new test setup, the smart remote with the Zoom 50 for OM4, is on screen, and we need to hit use selected. And that's it. We're now ready to go testing, and I've used nearly all of the 10 minutes that I needed to stabilize my sources. So the next step on the way to carrying out an actual test is to set the reference. And you'll see at the bottom of the screen there, it says set ref, which is obviously my favorite button. So we hit set ref, and you get guidance from day one. A 1 jumper reference is performed by connecting 1 TRC, test reference cord, from each output to each input. Well, I'm going to run the wizard because it's good practice to do so, and that will guide me in how to set the tester up. Please note, these cords are color coded, so they have a red end and a black end, and they have the encircled flux controller, otherwise known as the muscle, sitting in the middle of the cord. So we're going to plug in the red connectors, which I have previously cleaned and carefully not covered up too deeply, into the third port, third port on the top of the tester. That's one. This is the other one. I will tell you that I've embarrassed myself several times in the past by plugging those into the single mode ports, and guess what? It doesn't work very well. Anybody who's been present when I've done that will have learned some new words in Afrikaans, not all of them polite. So once we've done the plugging the red connectors in, we hit next at the bottom of the screen, and the tester says plug in the black connectors as appropriate. This is the first time I've actually done this at my desk as opposed to in somebody else's workshop. So let's see how this works. Double beep says everything's connected properly and well. And I can now hit set reference. And the unit will go away and go, the reference is set. Next, you must verify the loss of the additional jumpers. And at this point, when I do this live in front of customers, most of them look at me and go, huh? What? Why do we need additional jumpers? And I always say to them, think about it like this. You are testing 2 fibers. That means you have 4 connectors. In order to connect the tester to 4 connectors, you need 4 test cords. At the moment, you only have 2. So we need to add 2 additional jumpers, and we need to test their performance. So we hit next, and we disconnect the black cords. And we are going to install some extra jumpers. What you're hearing is me connecting and disconnecting the cords from my tester. There will be a small fist pump of celebration if I get this right. Ha! Right. So we add the additional cords that give us 4 in total. Then we join them together. So we now have 4 cords connected together, and then we run the TRC verification. And here we have our results. Now, the important thing here is people look at it and go, well, why is that important? The short answer is this is important because what we are looking at here is the total loss in each direction in the test equipment. So we have in one direction on the left-hand pair, a loss of 0.1 of a dB. On the right-hand pair, we have a loss of 0.02 of a dB. Frankly, guys, these losses are extremely small. But it does mean that everything that we are about to use as test equipment is in really good condition and is contributing minimum loss to the test result. And that's what this is all about. All this hassle and backwards and forwardsing and all that, this is all about loss. It's all about controlling the loss in the test equipment, making sure that any loss we measure from now onwards is in the installation. So we can hit next, and the tester will hopefully tell us to disconnect the 2 halves of the tester, and we will then be ready to actually go test something, which is what we're going to do next. Notice all the instructions on the screen. I don't know. Keep the caps covered up and all that. Very important stuff. Right. So I'm going to plug these 2 fibers into my installation, of which I have previously cleaned the connectors. Because, you know, sitting at home, what else do you do but clean fiber connectors? It's an exciting pastime. So every time you disconnect and reconnect, you get a double beep. There we go, double beep. I can go next. Connect to the installation, which is what I am, and I now go home. And I'm ready to run a test. So I press the test button. And the tester says, bidirectional test part 1 complete. Switch input and output fibers at the patch panel. Being a very obedient sort of person, I've switched 1 half, and now I'm going to switch the other half. And you will see that without touching the tester, it senses the disconnect and the reconnect, and it goes off and runs the test. And there are our test results. Now, okay, this is ready to use fundamentally. If I touch one of these big green boxes on the screen, it will show me the details. So I'll touch which one's nicest, this one. And it shows me which fiber we're talking about. We're talking about the output fiber on the main unit. We have 850 and 1300 nanometer loss. This is from the main unit to the remote, so from here to the far end. On the right-hand side here, you have 2 gray boxes, one of which says remote to main. So that would be the same fiber in the other direction, and I can touch that. And you get different losses in different directions. Let me just make sure I'm not lying to you. 4.5.4.6. Yep, that's pretty much what we'd expect. And the last box there is length. And if I touch the length box, I have my installed length for this fiber, the limit, which is 500 meters, and therefore the margin. So all of this data is available, all of this is there. So that is the left-hand fiber. The right-hand fiber likewise has exactly the same set of test result associated with it. What I need to do now is hit save. And what it's going to do is it's going to call the fiber that's on the input of the main unit fiber 1, and the fiber that's on the output of the main unit fiber 2, which kind of makes sense, assuming that we started testing with 1 and then we reversed the chords halfway through the bidirectional test. So I can now say save, and I have 2 test results sitting in my results file. Now, let me draw a couple of things to your attention. So I'm going to hit home on the tester because it takes me to this screen here. And I am going to touch the results button. And on the results form, you will find that you have 2 test results, 001 and 002, and 2 TRC results. Those are the test reference chord verification results for the result that we just took. And if I touch one of those so that we can look at the data, you will note one thing about this, and that is there's very little loss, which we already knew, but you will also notice that there is a length. Gentlemen, anytime we see a TRC verification that doesn't have a length, we know that the operator touched the TRC verification button without adding the extra chords. So that 2.18 meters that you're seeing there is the length of 1 test chord. The other one's included in the reference. So just be aware. To run the TRC verification without adding the extra chord is a form of misguided behavior, which we really don't want. So please take the TRC verification seriously. It is part of the repeatability argument. Okay, so going backwards, one of the things that I really ought to do is we ought to have a look at one other limit setting, and I'll use a new test to do it with. It's going to be smart remote, it's going to be bidirectional, the fiber type is going to be OM3, but the test limit is going to be more. And if I scroll up in the limit groups, we find vendor, and here is where we find CommScope. And CommScope have a unique loss calculator, which for a long time ran on an Excel spreadsheet. More recently, it's run on various types of tablet and mobile phone, but it falls into 2 distinct types, one of which is called Systemax Field Terminated, the other one is called Systemax Instapatch. And the 2 settings are different from one another. They both, hang on, we'll choose one. They both are entirely based on Systemax's loss calculator. So this is Fluke Networks and Systemax working together to come up with this calculator. It works exactly the same way as the Excel spreadsheet does. So you are required to, this is field terminated, you are required to specify how many connectors of each type you have. So in this case, 2 LCs, how many splices you have, 2, the reference is always 1. And if we hit done, that will be the test setup for today. Alternatively, go back one. There we go, more. We also have the Systemax Instapatch system, which is where you find the low loss LC connectors. And those are Systemax's best spec, I believe. LC connectors, that is where you find them. But this is also where you find the MPO connectors. Systemax configuration really depends on you knowing what type of connectors you've got, whether it's an Instapatch installation or a field terminated installation, and determining from that how you should be setting it up. But Systemax currently the only vendor who have committed to an immovable, if you like, or unchangeable loss calculator, which we can build into the tester in a reasonably civilized way. Right, so that's where we are now, and I am apologetic because we are already 10 minutes over time. And what I just want to do is, is to go back to this and to say, did I do everything on that list? Yes, I did, except possibly for the reference selection. The current standard, the current ISO standard recognizes only two reference methods. So let me choose ISO, and there are two reference methods available. There are two reference methods available. There is a 1-jumper reference and a 3-jumper reference. The 3-jumper reference requires you to have more test cords available, and it adds complexity while also adding the opportunity for errors and contamination. I don't recommend the use of the 3-jumper reference except in extreme circumstances. So I would avoid it if you can. Moving on swiftly, grading and documentation of end faces is, to my mind, essential. This is the as left configuration. So after you finish doing the light source and power meter testing, then you do the end face inspection and documentation of the end face, because you want to provide the client with reassurance about the condition of his end faces. But equally, this provides a level of protection for you, the installer, because it means that you have evidence of the condition of the fiber when you left site. And that's really important. I will say that IEC 61300-335, which is the only fiber end face condition and cleanliness standard, is a toughie to pass. It's not easy. The closer you get to the core, the tighter the standard is, and certainly it can be extremely challenging to pass. But whether you run the standard limit or not, provision of end face inspection images should be part of your documentation thinking. So here is documentation. This is a standard Linkware PC test report. As you can see, we have some stunningly beautiful loss measurements in this test result. And below that, the compliant network standards. Those are all of the application standards which would be fulfilled by this installation. It's important that you take account of this, because the installation standards that we have, the ISO, the TIA, and the EN, all have length maxima which are significantly greater than the applications. So unlike in copper testing, where everything's based around 90 or 100 meters, in fiber testing, the fiber installation standards allow for a degree more length than the applications will necessarily support. So you really do need to take account of that. Second thing, obviously, your end face images, these particular ones are not graded, but nevertheless, they are there, and it's quite clear to see that they are beautifully clean, undamaged, nice wheels on the sand and all that sort of thing. And last but not least, the date and timestamp on the end face images shows clearly that they were carried out after the loss measurements were done. So these are not end face images that were taken at some random time. They were taken after the loss testing was carried out. Right, gentlemen, ladies, I'm done from the point of view of presentation, from the point of view of playing around with the Certifiber Pro. Hopefully I've been able to give you some insight into how it works and what it does. Are there any questions? I don't have any questions at this point, which either means you've all gone to sleep, or it means I was really good, or it means I was speaking a foreign language, which is not impossible. Ladies, gents, if there are no questions, I thank you very much for your attendance. I thank you, those of you who attended twice today. I hope I have helped you to pass the time well. I wish you all health, happiness, and stay well, stay safe. And thank you very much for your attendance. Have a great afternoon. Adam, others of these coming up, I committed this morning to doing a short session on the OTDR, which I will do next week. I'm looking at various other copper and fiber things that are of interest. If you have something particular that you'd like me to talk about, please let me know, because my imagination is quite broad, but I can always use some guidance. Thanks, Adam. Thank you, everybody else. Take care. All the best. Thank you for the compliments. Appreciate those. It's always nice to know that that I'm appreciated. Thanks, Ian. Have a good afternoon. Ah, Daniel, now you ask a good question. When you clean your fiber end faces, what's the best way of doing this, and what equipment do you prefer? To my mind, the best method of cleaning patch cord ends, so males connectors, is to use acetone-based solvent and lint-free paper, either paper pads, or in our case, we have paper in a box. I prefer that because it is extremely reliable. As long as you remember that everything you're using is consumable. Don't try to reuse paper 27 times. I'm not truly a fan of quick clean or one-click cleaners. They do work and they're quick, but they will not clean off long-term dirt or baked on dirt or dried out dirt or contamination. They're good for a quick wipe, but they don't do a perfect clean. For cleaning bulkhead connectors or female connectors, I like not isopropyl alcohol. I like acetone-based solvent on lint-free paper and a series of swabs, preferably 2 swabs, 1 wet, 1 dry, into each port. All of this stuff is available from all of our distributors. If you're sticking with the Fluke network stuff, then we do a nice kit called the NFC cleaning kit, which you'll find on the website, or ask any of our distributors for, and they will be able to provide it. I also like the Cleatops cleaners as far as provision of clean, dry, lint-free material is concerned. They work really well too. You will tend to consume them relatively fast. Unfortunately, not having a live camera that I can rely on, I can't really show you end face cleaning in any great detail. There's quite a number of decent videos on our YouTube site covering cleaning though. Anybody else? Anything else? Right. Thank you all very much indeed. Take care. Who's left? 15 hangers-on still left. Take care, gentlemen, ladies. Be good. Bye-bye.